can access them via Canvas. Are you always considerably comfortable with Canvas? Because there will be a lot of Canvas work. Everything is online. So you will basically do your quizzes, your midterms, your finals, everything will be on Canvas. So please make sure you have functional laptops. If you don't have functional laptops, let me know beforehand. I will have paper copies of exams and quizzes on me, so you can do that, but you will need access to a computer. I have a paper allergy and I don't like paper. So good. Let me just quickly confirm that. Sorry for the little delay, but I'm just gotta make sure that the mic is on. Yep, okay. Speak. Okay. Good. Syllabus. I have posted the syllabus. You will find this on Canvas. And I just quickly want to walk through that. There are some peculiarities. So some of you have caught an entry of mentioning of data camp. Data camp will not be part of the semester. I have removed this from the curriculum. Those of you who are interested in learning more about coding, who look at me coding R and who review the codes and really want to learn more about it, let me know. I'm happy to do some extracurricular sessions of teaching you R a little bit more in detail. I can guide you to literature, I can guide you to whatever you want to learn. So the idea of this course, so I'm a scientist, right? What I do on my daily basis, I basically get people on the table and I make them interact with each other. So I work a lot with nephrologists, physicians from other disciplines. I work with statisticians, I work with mathematicians, I work with clinical researchers. So I get different people to talk to each other. So one of the aims of this class that I really want to achieve is that you learn the lingo, you learn the jargon, you learn the words that are being used on a daily basis when it comes to science and when it comes to stats. And I want you to read and interpret analyses that are being presented to you, at least in broad strokes, to understand what this is about, what you're looking at, which is essentially what you will be needing. Even if you don't do analysis yourself, you will see the printouts and the readouts of statistical software. So you will need that. I also want you to learn how to plan and design analyses. So when it comes to analytic design, when you think of your master thesis or your bachelor thesis or your master essay or any paper that you want to participate in, you will need to design your analysis and you will need to immerse yourself in a mindset of how do I look at this data to make sense out of it. And that's also what I would like to convey to you during the course of the semester. We're formulating null and alternative hypotheses, and we're testing it using statistical software, which mainly is Excel, but it will also entail R. That is a little bit more specific. We will do inferential statistics and descriptive statistics, and that is nothing we're going to discuss in too much detail today, but just in broad strokes, if you have data of a group of people and you're just describing them, and you say, okay, so there's an average of X, Y, Z age. So this population is 64 years old, versus the other population is 33 years old. You're describing them by quantifying an average for each of these two populations. And that is descriptive statistics. So basically you get like the central tendency of your population, of each of these two populations. You get a little bit of variability, that's the standard deviation. And once you're comparing them, you do inferential statistics because you draw inferences out of your data because you will say that these two populations are different from each other. So that's inferential statistics. That's a very simplified approach and it's a very simplified explanation, but that's pretty much what it is in some shape or form. Good. So these are really the objectives of this course. We need pre-installed software. So we need MS Office, we need some form of, any questions so far about the aims, objectives of the course? There will be questions, but I think for now, we're in a course. Good. We will need an Office, we need Excel. we need Excel to do simple tabulations, simple calculations. It will nothing be too terribly complicated, but it will give you a little bit of insights into Excel and how to use it. And you will profit from that. Trust me on that, you will need Excel in some shape or form moving forward in your careers. And Excel is just, having a good handle on Excel is a starting advantage. Good, R base. So as I explained in the video that I've posted, so there's base R. So basically R is an open source software, means it's totally for free. So there are commercial softwares that are costing decent amount of money. So it's like a good SaaS software costs you like $2,000 to $3,000, whereas R is totally for free and it's open source. That means that the programmers, statisticians, experts in the field have put their minds together and have together shaped a code library and a library of functions that is being put together in a software and that can be modulated, can be still modified, and allows everybody in the world to use it for free. So that's then compiled in a software that is called RStudio. And I understand some of you have problems installing that, and I will try to get to the ground of this, what the issue could be. Some form of a version mismatch happens, unfortunately, because you don't have a support hotline to call. That support hotline doesn't exist. So as a consequence of that, somebody who understands R needs to deal with that, and that is, in your case, me. So if it doesn't work, if I can't make it work, we're going to switch to Google Colab, which is the aforementioned online cloud kind of computing software, which is for the simple applications that we will be using sufficient. Good. Any questions to any of this? If not, we can talk about the textbook. So I hope all of you have seen the textbook that is required for this course. It's a pre-psych intro to stats textbook. So the examples are very psychology oriented. As said, I'm also not a psychologist, so I will comment on tests or whatever is being described to the best of my knowledge. But don't challenge me too hardly and harshly on that. So I'm not a psychologist. But yeah, I understand the underlying stats, and I will explain you that example to the best of my understanding with the underlying statistics that are being presented. And it's simple examples, very simple, but it's a use case that really could be used and studied in psychology. And that's the beauty of it. So we will do pretty much with every module, we're going to have one example where we're actually doing Excel calculations. And we will walk through the mathematics of the underlying statistical method. And I believe in that because only if you understand each step, you really understand the concept behind it. Not really something you will be challenged on. So the homework will entail some calculations that you have to do, which is usually where students stop liking me. And then for the quizzes and midterms, you essentially will not have to, well, you're advised to use Excel, but you can also calculate by hand, or you can use calculators. Usually I see some Texas Instruments. That's perfectly fine that you use that. So it's open book. All my quizzes and exams are open book. Because I think if you know where to look for the information, you have learned enough to pass the test. So also keep in mind, and this is essentially the 5 hours, yeah. Keep in mind the evaluation criteria. So I have sat over this quite a while, and I'm a numbers and data guy. So I have put a lot of thought into this. So you have 3 quizzes. These are basically easy. This is sandbox. So this, you see where you stand. You see how well you have understood it. You will, in addition to that, you will have practice quizzes. So see it in that way. So you have a huge pool of questions that I have assembled from a question test bank, various test banks essentially. So we're talking about close to 2,000 questions. These cover, no, it's actually could be more even. I gotta check the exact number, but it's basically, it covers all the modules that we're going through. A subset of that I use to create little practice quizzes that are randomly assigned. So everything runs random. So everybody has equal chance to get the tough questions or the easy questions. And the randomness generator is not created by me, that's Canvas doing for me. So randomly sampled questions that you will get for the practice quizzes, and then randomly sampled questions you get for the exams and for the quizzes that are actually scored. The practice quizzes are being posted with each module. No points on that, no ramifications. If you fail them, it's just for you to kind of practice your own knowledge. Please don't take it too easy. The practice quizzes alone will not be enough. So you will need to read, and you will need to be in lecture and go along with what we do. Good, but we have the quizzes that are basically setting you in the right knowledge group for midterm and final. Midterm, you get 150 points, and this is the tough one. So that's 350 points. That's the final. So you will need to go along with the knowledge. It will be open book. You get ample time. It's not about time, but it is about you following along. You have 3 homeworks. Shouldn't be too tough. We have the participation. Sorry. And I have thought long about how to grade a participation, right? So I actually was tempted at some points to have like this random samples where I kind of see where the class as a whole stands, that I pick out with every module, to take this as kind of the grading. And I will go in my overall evaluation, but it's not what will be a make or break. It's essentially participation are these videos that I'm posting. So you have already 2 videos posted, which should be accessible to you. I want you to watch those videos and comment on those videos. Usually ask a question. For those who don't ask a question, just give me a general comment, general thought of what is being shown. And it's interesting videos that are not only about statistics, they're about general use of statistics. This will in the end, so there are some really cool videos in the end which talk about artificial intelligence and how it's being used for creating driverless cars. And those are really hot topics, and topics that are still relevant. So it's really more about the use case. The current 2 videos, particularly the first one, that's the creator, that's the inventor of spreadsheets. And when you watch that video, please really think about what I told you about Excel, how important it is to know Excel, because all this work that you do in Excel within seconds had formerly been done with piles of paper, and it was extremely labor intensive. So we are really in a very lucky spot that we can do all of these analyses very, very simple with very simple tools, which you just need to learn how to master. Good. Any questions? Open book. You're gonna like that. It's not bad. Good. So we have, okay, what's next? So next, practice labs. So this is just a different wording. Yeah, great. I have to, but this, yeah. So basically everything less than 650 fails. We have D, which I don't have for my graduate classes, but seems to be common to be used here. So it's basically, it's kind of a grading scheme that you should be comfortable with. Okay. So today it's just me rambling on and telling you stories about how I envision the course. Next class, no, actually that's nothing. Next class, we're talking about stats. We're talking about data, we're talking about stats, we're talking about research design. Does anybody have an idea what research actually is? In the greater realm of things, what do you try to do with research? Yes, please.
I think research is used to provide doctors and pharmaceutical companies and healthcare companies with useful, up-to-date information treatment plans and
Okay. It's, I would go further. So researchers are not only companies, right? It can be an academic setting, can be a hospital. It's like literally in the US, if you plan to go into medicine, for example, as a resident, you will need to do research. So it's true. Researchers try to make sense out of what they're seeing in their patients or in their study patients, the study participants, and they try to make sense out of those interventions that they have placed, like can be an antihypertensive medication, blood pressure medication, right? So you're lowering blood pressure, you want to compare it to not giving a blood pressure medication. So you try to find insights that you can use for a greater population in a subset of this population. Yes, please.
I was just going to say, like, broadly, it's basically collecting data and asking questions and then finding, like, hopefully finding solutions to your question.
Yeah, that's a research question, exactly. The researchers that have a certain research question, ask these questions, studied in certain populations, looking for dynamics, looking for what can be labeled, and I like to label, I like the term, for a signal. They're looking for a signal of an intervention, of a disease, or whatever you're looking for, and you're basically searching for that signal. And you're finding the signal with statistical tools that you employ on the data that you have collected. And everybody wants data. It's everything is about data. And this data, this is why stats is important, because stats allows you to make sense out of your data. Good point. Thank you. Good. So on Wednesday, we're going to talk about the basic principles, research and design. We will talk about the different design types that you will find. So in principle, you have design where you just look at data. So you look at a group of patients and you observe them. That's observational research. Or you have experimental research where you actually do something. So you give them a drug or you don't give them a drug in the simplest form. So you have some form of intervention or some form of experiment that you employ. Frequency distribution, we're talking about visual displays. You need to make sense out of this data, not only in numbers, you also need graphs. And this is what we will cover in module 4. Then we'll talk about central tendency and variability. Sounds fancy, is not as complicated. It's basically central tendency is a mean or a median, which basically gives you kind of a feel for that population. What's the mean blood pressure? What's the average blood pressure? That's central tendency. And then the variability describes how much do people deviate from that mean. So that's variability. Then we talk about sampling and probability. So this is a little bit more mathematical inclined session. So we talk about sampling, which is basically how you sample your study group from the overall population, that you actually get this signal out, that you actually get this data that you want to study. Probability is probability calculations. This is a little bit more on the drier side, but also an important part of it. Then we are skipping 2 classes. We're skipping actually quite a few classes, and we only continue on 1024. And this is the month I'm talking about. So that's a little bit problematic. So I'm a little worried about that because it's particularly long this time. So there is one remote class that we could have, but I chose not to have this class. We can have it if there's interest for a review. But we would continue here in 1024 with the normal curve. And this is where it increases a little in terms of the steepness of the learning curve. So we're coming 1024. We're talking about the normal curve, how we're standardizing data, how we calculate set scores. Then we come from hypothesis testing, and this is already where we're moving into inferential statistics. And this is basically comparing the groups and finding out whether they're significantly different from each other. We're moving then into confidence intervals, which is a characteristics of these hypothesis tests. We talk about effect size and statistical power, which is essentially how you, that's basically the backbone of your hypothesis testing. And then we review, we have a lab day. Which lab days just explanation. Lab day is usually a lot of Excel and R, which basically in those lab days, we're going to do the practice labs. The practice labs are basically R codes, which we're going to walk through. We're going to do R programming, and we're going to confirm in R whatever we did in Excel. So you're not going to learn anything new with R. It's going to be a repetition of what we did in Excel. So I'm just walking through the specific examples we did in Excel, and you get the repetition essentially in R. So that it's also easier for you to kind of follow along. Then we have a review session, and then we have the review. So that should not be too hard. It's never been a major problem for most. The quizzes will help to some extent to find out where you stand. So there's no quiz before this, but I hope you will do the practice quizzes and you will kind of see where you stand. But the first half is not too tough. It becomes tough with normal curve hypothesis testing and the confidence intervals, and this we will repeat quite abundantly. So that's why I have 2 sessions for confidence intervals. Then we have the lab day where we can talk more about it. So we will go through this over and over and over. It's very essential. Good. And then the second half, and the second half is a little tougher. So I designed it in a way that we start with the actual t-distributions, with the actual sample comparisons only after the midterm, which I did by design. And we're doing a single sample t-test, paired sample t-test, independent sample t-test. We're reviewing this in the course of a lab day. Then we get to an analysis of variance, which is basically comparing several groups at the same time. That's a little tougher. That is not easy. And then we move on to correlation and linear regression, and we come to chi-squared test. So it's hypothesis testing in different settings. With a t-test, you're comparing a certain continuous variable. With linear regression, you do something else. You do correlation analysis, and you're quantifying associations between variables. And then with chi-squared test, you're basically comparing counts and percentages within a group. So you have like, I don't know, you have 40% women in there, another group, you have 60%, and you're comparing whether this is significantly different. Then we're reviewing shortly before Christmas, and then we have final exam on 12/28. Any questions on that? So again, the deliverables are essentially homeworks, 3 homeworks, 5 practice labs, practice lab submissions, which basically you just need to follow along with me in class and do the practice labs and then submit whatever we coded. I will want to see that you followed along. And then the quizzes, midterm and final, and the module post. Those comments. There was 5 points for each submission. So that's basically how you gain points. Overall, it's graded with 1,000 points. 1,000 points with 100%, and then you basically have the grading scheme as presented here. Good. No extra points. I don't really believe in that. So no extra points. Submissions, assignments that are being delivered too late, I'm willing to negotiate beforehand. If you tell me, okay, so we all have like as many assignments due at the same time. If we as a class decide we do it 3 days later, works for me. If you individually 1 day late, I may be okay with that. But at one point, I start deducting points, and that starts with 10 points per day. So this is just to keep things on track, and I'm not too picky on time, and like if you need more time on an exam, time won't be the major issue. Just make sure you follow along. All right, any questions to anything of that? You have basically the general outlines, accommodations, please send to me as an email. Use of electronic devices, laptops are required during the exams. And I used for the finals, I get a proctor who helps me. No messaging services, no emails, no Google. But you can use the PowerPoint slides. You can use the book, perfectly fine with me. You can use your notes, fine with me. Electronic notes, also fine, but it needs to be only those notes. All right. Did I forget anything? Yes.
When are we gonna start using the book? When are we gonna start using the book?
The book?
Yeah.
Next class on Wednesday. But don't worry, it's like, yeah, but that's a good point. You will need the book by all means. If you, for example, have a previous version, not a big problem, I assume. The examples will be different. That will be a little bit of a problem. But again, it's like all the Excel spreadsheets are posted. You have the recordings. You see exactly what I did. I have the blank Excel spreadsheets online, and I will have the completed Excel spreadsheet online, so you can go through the class on a spreadsheet. Yeah, the materials in the book. You will also get, and this will start with next class. So this is a typical module. God, this is terrible. Who wrote on this? Okay, so this is a typical overview of a module. So basically you have an overview. So it gives you a learning checklist. You get a main lecture that contains the Zoom link. You have here a PowerPoint presentation. The PowerPoint presentation is the material. I will walk through that PowerPoint presentation, and the PowerPoint presentation will contain the example that we're going to do in Excel. And you will basically see PowerPoint presentation presents the example. I will show you how to derive that in Excel. Then in the practice lab, we do it in R. So it's basically preparing you well for that use case that is being asked. If something like this is added, this is a so-called R file. So this with the ending .r, this is an R file, which basically is for the Stroop data example, which we'll discuss next class. So we have Stroop data.xlsx. That is an Excel format. So I don't know how computer savvy you are. Everything after the period is basically indicating what kind of a file type it is. If it's R, it's an R file. If it's XLSX, it's an Excel file. You have then following the online discussion topics, which are these. So you link to the discussion board. You have here the practice quiz, which is giving you a taste of that lecture, of that particular topic. The readings, which gives you that chapter of the book. And then additional supplement, this contains like additional videos that I found interesting, or if something is in there, something in addition to what we have discussed in class that may help you understand the concept. Virtual office hour, this is, if you want to have office hour with me, happily make myself available. I have a full-time job and I teach now 3 classes this semester. So we need to schedule it, but I happily make myself available. Whatever question you have, we can always meet and go over the details. Yes, please.
Sorry, are you posting the textbook readings or?
Not the readings. I just did the chapters essentially. It's really, it's like you gotta read the chapter. I try to be very, very accurate about only using questions that were in some shape or form discussed in class. And you should be able to answer with what we have discussed in class. As you can imagine, it's quite a broad field. Sometimes there may be a detail being asked in a question that may not be discussed in that shape or form it's being asked for. And it definitely is of value that you read the chapter. It makes sense. I think that's it's a reasonable approach. Any other questions? All right, good. So before we carry on, then I want to be. So the beauty about asking for attendance is that I also get to associate now faces with names. So I would please ask you to go along with me for the roll call, the attendance roll call. So Adina Adler. Hi. Kayla Ashwasade. Was that okay? Ashwasade? No? Yeah. Okay, Kayla. Nice to meet you. don't hold it against me. Say it again, please. I'm sorry. Ashwasade.
Yeah.
Okay, good. Excuse me. Elisa Balsam. Balsam. Julia Benarok. Hi. Benarok. You gotta forgive me. It's like I come with an Austrian German accent, so it's like it's although I speak with a very broad accent, so I hope when you have troubles understanding me, please let me know. It's like I've heard that it's sometimes hard to understand me. Samantha Benjamin. Hi. Brooke Bloom. Hi. Danielle Botnick. No? No. Yehudit Cohen. Hi. Emily Dinner. Hi. Kyra Elbaum.
Yeah.
Hi. Kira. Thank you. Eden Elikan. What? Oh, hi. Shoshana Ellis. Hi. Shoshana Epstein. Hi. Lauren Fishman. Hi. Do you want light in the back? It's a little dark. Are you okay?
What?
Do you want light in the back? Or it's a little dark in the back. No? Okay. Okay. Golda Goldberg. Hi. Emily Goldstein. Hi. Seema Greenberg. Hi. Nava Israel. Hi. Myra Fianos. Myra Llanos, that's you.
Yeah. Me.
Yes, not you. No, you know. Okay. Lindsay Kalish. Hi. Myra Kanofsky. Ah. Okay. Madeline Casti. Is that an L? That's L. Casti. Madeline Casti. No? Do we have a Madeline here? No? No Madeline. Kayla Miodovinik. Hi. Haley Orge. Hi. Call me out. If I mispronounce anything, please call me out. Olivia Pella.
Here.
Hi. Mia Perlman.
Yes.
Hi. Mira Postelnik. Yeah. Hi. Melissa Rosen. Hi. Daniela Rothschild. Hi. Daniela Samuels. Hi. Sophie Schanzer. Hi. And Eliana Siklik. Hi. All right. Good. It will take me a couple of sessions until then we have a month's break. But I'll get to it. I'll remember your names. Okay. Anybody who I did not call? No. Good. Okay. We went through the syllabus. Now let's look into some initial things. So I just want to show you a slide which started my educational statistics. So that was I have stolen this slide from my academic advisor and friend, so he knows I've stolen it. So this is it's terrible with the writing. There's not really one of these sprays. Have you had a class in here already?
It's just hard to hear the back. It's people loud.
Yes.
Sorry.
No, not a problem. So there's nothing to clean there. Okay, I hope you still can see. All right, that was a particularly good idea. Okay, good. So this is the timeline of statistics. What the timeline of statistics here shows is from earliest time on, there was data around. There were numbers around, and these numbers were utilized in some shape or form. And there are various examples how that actually was done. Mathematics found back in Babylon and then later in Egypt, they used mathematics to quantify things, to understand things, to establish associations and connections between things, objects, and people. This goes then further than in the medieval ages. You have here Reverend Bayes, who was a great mathematician, actually, cleric from the UK, who was inventing a theorem which is to this day used for quantifying conditional probability. So you really have a long history of all various use cases for statistics. And this just makes the point how important it is and how important it has always been. Nowadays, the use case of statistics is like everything around you uses statistics. You pull out your phone knows what likely you will be opening. Your phone knows what you will be doing next. Your phone essentially knows so much about you that you don't even know you know. So Amazon suggesting to you what you want to buy, what you may be out of, and what you actually is lacking, or what you actually would really want to buy. Amazon is doing that with artificial intelligence. Artificial intelligence is essentially nothing else, in a very simplified form, nothing else but regression analysis. Well, very simplified form, but it actually bases on something which we'll do in the second half of the semester. It's associations that are being utilized to make sense out of information that is being quantified and then used for inferential statistics, which are then being used to create an outcome. And that outcome is you looking at your phone, you're being tempted to buy what Amazon wants you to buy. In addition to that, you have an additional layer in between. So you have Amazon and you have the consumer. In between, you have what facilitates or even allows for Amazon Prime, because Amazon Prime gives you, I'm using actually a brand name, which I shouldn't, but it's just such a tempting example, because they are known to collect so much data and utilize so much data. So essentially what they do, they predict what you will be buying, and they're buying this from the supplier, putting that in an intermediary warehouse where it just lies around, and then they're basically expecting you to order it, you order it, and it's within you from the nearest location where they have stored it. So they're predicting what you will be buying using artificial intelligence, and that's STAT. So it's really all around you, and it's all around you in a shape or form where you don't recognize it. But this is why I believe there's a lot of value for gaining insights into the underlying dynamics and the underlying mathematics, because that's what it is. It's mathematics that are basically being brought to a use with codes like R that I show you. Other codes would be Python. So there are various coding languages that are being used to create exactly these algorithms. And this is the timeline of statistics. So we're basically in an entirely new age where we have so much data of our consumers, our patients, our research subjects, of everybody, that making sense out of data is really one of the most important things of our times, essentially. And the number of examples of companies, institutions that do exactly nothing else but collecting your data and making use and sense out of your data is limitless. It's like so much happens to your data that you're not aware of. So we live in a time of big data. And that's actually something that I will say quite often during the course of the semester. Big data quantifies a vast amount of data that is being collected on a routinely basis. And how vast that amount of data is, just as an example, I do research in dialysis therapy. We have patients come in 3 times a week. We have 52 weeks in a year. That's 52 multiplied by 3. That's 156. 156 times we have one patient. The company I work for, dialysis 200,000 patients. So now I have 200,000 patients and you get 156 data points over the period of a year. And you get for each of these data points, each time the patient comes to dialysis, you get 500 variables. So now imagine that spreadsheet, right? Those of you who have already an idea about spreadsheets, that's 500 columns, 200,000 multiplied by 156 times 1 year. We have data of 20 years. So it's enormous. And that's not even close to how much data they are circulating. It's like all the data that has been collected. So there's the statistic. And I've seen that in an absolutely brilliant talk of a working colleague of mine. The data that had been collected over the last, I think it was 10 years, is basically exceeding the amount of words and letters ever written in the history of mankind. Let that just pass through your mind and think about how much data this really is and how new these times actually are. We are transparent, we are understood, and you use a phone, your cell phone provider knows everything about you. So it's just interesting. And it's very philosophical, and it gets really an interesting terrain where we're moving as a society. Good, but enough about that. Let's just talk about some definitions. So we will be talking quite a bit about populations. So basically, a population is a group of people, a large group of people. If you talk about the world population, it's a lot of people. If you talk about a smaller population, you look for American adults, smaller population. Look at even smaller population, you have residents of New York. Just examples, right? So these are populations where you discuss an entirety of some shape or form or definition of a population. If you have a sample, and that's where this becomes an interesting distinction. A sample is a subset of this population. So you take a certain sample of your population and you study that samples, and you made that point. You forgot your name, sorry. So you made this point. You study a sample and you ask a certain research question. And you essentially want to see what happens with this sample population, sample of the population, sample population. And you make sense of that with data, with collected data. And once you made sense out of that, you try to extrapolate it to the overall population. So you go out on the street of New York, you survey 10 people, and we'll talk about sampling. You survey 10 people, or you survey 100 people. Is this representative for entire New York? You don't know. But you're trying to find a sample of the overall population that represents the population as a whole. So that's really what research is. So the definition here is a sample is a subset of the group or population of interest. That's a little different. So a census is basically where you try to get a cross section of the entire population, which is the US Census, for example, is one of the largest endeavor of that kind. And of your sample, each single observation is called a record. And that's essentially what data definitions are. And now we're talking quickly, and we will get to that back again on Wednesday. I've talked too long. So we're getting back to that on Wednesday. So descriptive statistics is describing a population. And this is older than this actually to describe population, but these are the first attempts to describe population dynamics. So this is the conquest of pestilence in New York City. It's actually, I am in my background probably to be labeled as an epidemiologist. Epidemiology means to quantify the disease burden in a population, be it infectious diseases like we just had to suffer through a pandemic. This is epidemiology. If we talk about cardiovascular disease in population, this is epidemiology. So they quantify the disease burden and they try to create knowledge and insights that will lead in the longer run in hypotheses that can be pursued in experimental research and can lead to an improvement of outcomes of a population based on that insights of the sample population. But basically that's descriptive statistics. And you can see when you look at these descriptive statistics, you can see already how easy you actually could draw quote unquote inferences from that data, because you see these spikes and you see the associated outbreaks of various diseases. So you can make inferences out of your descriptive data. So when here, this is death per 1,000 population. So this is a mortality rate. If the mortality rate increases because of a cholera epidemic, you can quantify the step change and make inference about the devastating effects of cholera in the population. That's inferential statistics. I find that super interesting. I hope you do. But yeah. So, okay, so this is descriptive statistics. This is inferential statistic can then also be essentially drawn from samples. So you have samples, and this is being done very often by surveys that essentially are the approval rating of presidents, for example. In political surveys, you hear this quite a bit. So you basically hear approval rating, and you have here what is called a time series, because it changes over time, because this is when we like the president and we don't like the president. When we like him again, then we stop liking him. So it fluctuates. And what we get around here, this is the variability. That's the so-called margin of error. And I'm sure you all have heard that on the news. And this is basically what it quantifies. And the margin of error, this is our confidence interval session, because this is what we're going to learn how to calculate it there. So this is a marker of variability in a population used for inferential statistics, because if the approval, so now just to give you a quick insight, you have your approval yes, approval no, or approval no, approval yes, probably red is more negative. If this variability, this margin of error is not overlapping, this is statistically significant different. So this is how you quantify differences between those two time series. And this is what I will be plaguing you with this entire semester. Good. All right. Any questions on that? Or absolutely overwhelmed with this information? Okay. So again, I enjoy my topic. I sometimes get carried away. My examples get too specific, and you just gotta stop me if it's getting too specific and I lose you. Okay, so this is inferential statistics, and this is basically what we do. This is what we do in research, and this is what statistics offer as a tool to essentially study. If no questions, so 5:38, so we have 17 more minutes. So we can then actually look quick at the Excel spreadsheet. We will likely not get to R, but let's see. So all of you, I would ask you for one thing now, please. Open your Finder window. Make a right click on your desktop, press Control, and click one time.
Wait, please let it get.
Okay, so I changed my hat now. I become now an informatics professor. So we're pressing Control, we're pressing on desktop, and we're creating a new folder. Open the Finder, go on your desktop, make either a right click or control and left click. Either or should work. And you get a pull down menu. You get this pop-up menu and you create a new folder. Everybody, okay, what's the problem? Yes, you don't have a Finder, you have a Windows Explorer, you press Windows and E. There should be a desktop, you find your desktop, you make a right click. Okay, ladies, one after another. If there are questions, please address them to me. Okay, so you have an IBM ThinkPad. That means you need to press Windows and E. It should open the Windows Explorer. And it should open the Windows Explorer. And then click on Desktop. And make a right click on the desktop and open a new folder. Yes. You create a new folder. Yes. Just create a new folder. That's just step one. Don't worry about it. Just shoot me an email and tell me if you get stuck. Just let me know. If you get stuck somewhere, just shoot me an email. Okay. Have we all created a new folder? Yep. Okay. This new folder, please label STAT1021. Yep. I'm very innovative, very creative. Okay. So this folder, you create new folders in there. You create new folders in your STAT1021 folder that are labeled module 1 to 26. We're creating new folders in the STAT1021 folder. Module 1 to 26. So you don't need to create all of them, but for each module, please create a new folder. This will help you to keep an overview over your folders and all those files that you get from me, because you get a lot of files. Excuse me. Hello. One after another, please. Excuse me. All right. You create a folder called STAT1021. Just try with a right click on the desktop. On the desktop, right click. Did it create? Did something pop up? No. There's a desktop. You do a right click. New. That's how it works. All right. Okay. Can we collectively focus again? Okay, where do we stand? Okay, so module is module 1 is a subfolder in your STAT1021 folder. And I'm doing this exercise with you because I want to help you, because once we're at module 26, you will have a hard time distinguishing. I do file labeling. I try to be quite diligent, but you may get a little confused with the different files you get from me. You get Excel spreadsheets, PowerPoints, R codes. You will create your own spreadsheets. You want to have order in there. Trust me on that one, please. Okay? So do module-specific folders, do homework-specific folders, and just help your future self to remain organized. Yes. Hi.
Should the homework folders be in the module folders?
I would not. I would keep them outside. So I would make it look like this. I show you as an example. I would design it like this. So this is my folder. Oh, not this one. So I use to put files in there. If you want to download your PowerPoint presentations, which are essentially something that you can use for your exam, because that's open notes, right? So I would suggest that you know how to find them. This just makes things a little easier. You will have ample time, but maybe not that ample. So in essence, how it should look like is like this. No. It should look like this, where you basically have all your folders organized like that.
Wow.
You understand now why I'm telling you this now? Okay, just please roll along with me. Do it that way. Remain organized because you have your class folders and you have homework folders. You will have in the syllabus the information which is in which module. And you find your information fairly fast. But you will need this. Yes.
What do you suggest we put in a module folder? That's where the power.
I would download whatever you can download, which is essentially you can download on Canvas, but just clicking on the file. This will open up. It will tell you download, and you download it, and then you search in the pop-up window. You search that module folder. There will be a homework folder. Yep. I'm still working on the homework because you're gonna get a different homework because I'm working now on getting new generation of class out because there was some repetition over the years. And so yeah. Yes.
Hi, sorry, I'm so confused. How many total folders do I have inside the STAT?
For now, just make one. Make one with each class. You don't have to create all the modules now. Just do when you start off. Okay, so now we're gonna see again on Wednesday. I would suggest if you download the files for Wednesday, create module 2, a new folder, right next to module 1, and copy those files in there.
No homework folders right now? I shouldn't make any homework folders right now, just module.
Well, you can. You don't have to yet, because the homework hasn't posted yet. That's only comes like a
Module 1, pick one folder, module 1.
module round for one. For now is perfectly fine. Yeah. Yep. Sure. So it's really, but the reason why I'm telling you that because this is what I've observed. So I'm teaching this class now the 7th time. So I've seen just over time what is an area for improvement. So I'm trying to help you. You're welcome. Yep. It's a lot of files, trust me. Okay, so this is this. So now we have, from today's lecture, we have in our STAT1021 folder exactly these files. These are downloadable. We have this PDF I just showed you, and we have here a practice spreadsheet, which is an example that took me a long time to prepare. It's so simple, it took me 2.5 minutes. But essentially, what it shows you is a time series. It shows you time series data. So let's say Teresa, Sarah, John, Nicole, they did, I don't know, this sold something. I don't know what they sold. Newspapers, Bitcoins, I don't know. So you basically have these entries, and this is how you will encounter data in real life. So there are two formats. There's something that is called a wide format, where you have, for example, 2018. So you have here 2018, 2019, 2020, 2021, 2022. So basically in the wide format, you have these numbers, these distinguishing factors, basically mapped out in the wide format. For each year becomes one separate column. Disk format is something which I sense you don't like it, but it's more intuitive for me when I look at it, because I see that the names are repetitive. It's the same names repeatedly. The age increases by 1, the year increases by 1, and the earnings are different with each row. That means there's one common denominator, which is the name and the year. The age is just a resultant. The age is not important in that sense. That's just the difference from the birth year, which is unique for that individual and that respective year. And then there are different earnings for those sold Bitcoins. So now we can do various things with that. So if you click on any cell, you see two things here. You see up here on the very left, you see the cell location. And this cell location is very important because that allows you to localize the cell. And so this is on D2, this is D, this is 2, this is D2. And you see here the actual value, the numerical value in there. This numerical value can also be referenced by making an equal sign and clicking on the same value, which you want to refer to. Because now 105 is translated into equal D2. So you just copy it over, but you reference it from that cell. Because if I say now, so now I have this reference value there. If I say now I want, can somebody tell me how I would calculate 110% of that? And 10% increase in earnings. How would I calculate this? So if I have 105, how do I find out what earning that the individual would have made if they would have made 10% more? Yeah?
Well, 10% of 105 is 10.5.
Correct.
So you can just add that to 105.
Correct. So if you divide it by 10, right? So 100%, 105 is 100%. You divide this by 10. You divide this by 10 is just as you said, 10.5. And you add this and this gets you 115.5. Easy, right? Another way to do that is, and I'm telling you this right now because things like that will come your way. You take this value and you multiply it by 1.1. Because 100, you can essentially, percentage and proportions. Proportions is essentially a decimal from 0 to 1. So if you divide, if you consider this a 1 or 100%, you essentially can, by multiplying it by 1.1, you get 1 and a tenth of 1 added. So this is multiplying it by 1.1. This is 110%. So this is an important distinction between proportions and percentages. You will hear, so there's a certain number, a certain percentage that will reoccur more often, which is the so-called p-value, which essentially is a proportion. It's being reported as a proportion, but it's essentially probability and can also be reported as a percentage. This distinction is important. So please go back to your high school books and make sure we're on here on that. So this will come back. So that's why I'm mentioning it. Good. What else? So you can literally do all these calculations. One thing which is also in my Excel recording. So please go through that Excel recording. If you want to do this now with your entire list, so you do multiply by 1.1, you get the 115.5. You want to propagate this formula now. You want the very same formula for all entries. The only thing you have to do, so you entered now a formula here. This is D2 multiplied by 1.1. You want to complete this now all the way down. You just go to this cell. You go to the right lower corner. And did you notice that this white cursor, this white cross, now changed into a black cross? And once this happened, on the right lower corner of your cell, and you double click it, it completes the formula all the way down to the end of the data series. This will be necessary when we do calculations. Yes.
What's the formula you did to get to the
Multiplied by 1.1.
And you said that was exactly what was the
That's equal to adding 10%.
Okay.
So you can do the same thing in R, which we're not really getting to. Just, yeah. It's 554.
Copy is the spreadsheet into Excel?
The spreadsheet, no, you just open it. You download it in module 1 folder and you double click it. It should open it automatically in Excel.
Open an Excel field with numbers.
Yeah, that's a problem. Can you make a right click on the XLS file and say open with and find the Excel there? So the way this looks like is, if you make a right click on it, you have open with, and you have here Microsoft Excel. You can go here on other. It will give you a whole list. Yeah, it gives you here a list of applications that you can find in your application folder. You pick Excel and you select always open with, and then it will from now on only open it with Microsoft Excel, because numbers I would not recommend using it. Yes.
Can you repeat how you get the whole column down?
Yes, absolutely. You have the formula.
Yeah.
So you have D2 multiplied by 1.1. You go in the cell and you see now how this cursor looks like. I go to the right lower bottom of the cell. It changes in shape, and then double click it. Yeah.
Is there a way to open what you posted on Canvas on the wall you like Excel online?
Yes. You should be able to open it. If you just go on open, did it work when you logged in?
Yeah, I have it.
Okay, perfect. Let's just spread the knowledge. Yes, you have a question?
Yeah.
Sorry, soon.
Can you repeat how you did the actual multiplication?
The multiplication. You basically you use equal sign D2. Multiply sign is shift 8. There's the asterisk.
Yeah.
The asterisk and then whatever number you want to multiply it by. So if you do 1.1, you get exactly what we just had. So the asterisk is multiplication, slash is division, and plus and minus is self-explanatory. Yep. You were next. Sorry. Yes.
Yeah, so when we're putting the formula, how do you get it to download it?
So you enter the formula, you calculate multiplied by 1.1, right? Yeah. And then you propagate it all the way down. And once you propagate it down, essentially you have the list completed. Yes, please.
Can you click on cell F2?
F2, yep.
What were you trying to do?
Calculate 10%.
10%?
Yep. So if you consider 105, 100%, and you divide this by 10, you get to 10%. Yeah. All right. Sure. All right. Thank you very much. It's 5:55. We're done. Thank you for your attention, and let me know questions.
Okay, it's sort of related, but not really. It's just about Excel. I have an internship where like I do a lot of this with
Yep.
data and
Yep.
graphs,
Okay.
all
Good.
that jazz.
Yep.
And I was asked to make. I'm finding all the averages, like the
Average.
averages of all the averages,
Okay.
and then putting it into a bar graph. So I
Okay.
cut these sweat. But they also want me to do a scatter plot within the bar graph.
A scatter plot within the bar graph.
Yeah, like here's the number,
Yeah.
and then inside of it, like I guess the whatever is all the meat made up this average with number.
I would probably try to make this
Can I do that
in
in Excel?
Excel.
I do it, but he said like you can figure it out, and I was like, oh, I use Excel this summer, but
Not in Excel. Well, in R it's easy, right? In Excel, I wouldn't know an easy way to do it. Did you go through the? Okay, so I'm ending recording. Thank you. Bye bye.